Okay, let's do 15. We got chain rule again. Okay. This doesn't help me, but I know it helps some students because when I explain it this way, they went, oh. All right, so let's go. Outside function, inside function. We got two functions here, and if ever you could break up a function into two functions, then you must do a chain rule, as long as one of the functions is inside the other function. So what is the inside function? I normally identify the outside function first. What's my inside function?
X over 2?
Yes, so my inside function is x over 2.
Where's the outside function? 3 sine.
Yep, outside function is 3 sine x. All right, you guys good?
Yeah.
Ready to roll?
Yeah.
All right, it is derivative time. When you do derivative, the chain rule, you do the derivative of the outside function first. Then you multiply it times the derivative of the inside function. So, oh, and by the way, you can look at x over 2 as 1/2 x. It's all about manipulation, people. Look at that. What's the derivative of that? You can see it really fast now.
No.
It's just 1/2. No, it's not. Make noises. Okay, what is the derivative of sine? Cosine. So you have 3 cosine. And then what's inside of it right now? X over 2. Don't forget to keep the inside function inside the outside function when you take the derivative of it. Then I'm going to go times the derivative of the inside function. And what is the derivative of 1/2 x? That's this. It's just 1/2. So we have 3 over 2 times cosine x over 2. Do we have something to plug in?
Oh, what happened to the 3 sine?
Nope, nothing to plug in. We're done.
Is that it?
Sorry, that's only the first derivative. I got to do it again. Okay, so that's the first derivative.
Wait, what happened to the 1/2?
The 1/2 multiplied to the 3. See, I got 3 over 2. Good question. Okay, so now I still have an inside function and an outside function. Okay, this time my outside function is a 3 over 2 cosine, but the inside function stays the same. So let's take the derivative of cosine. What is the derivative of cosine?
Negative.
So I have 3 over 2 negative sine, and then I keep the x over 2 inside. I have to multiply this times the derivative of the inside, which is just 1/2. And so this simplifies to be negative 3 over 4 sine x over 2. Boom shakalaka. There's the second derivative. Second D. Do 16 just because there's a short way to do it and there's a long way to do it. I'm going to try to do it the short way. I'm also going to call it the Eric way because he reminded me of it one time. All right, so we have...
Can we do the short way first?
Yeah, we're going to only do the short way. I don't have time for the other one. Okay, I'm going to say that's the first function, that's the second function. So I get 2 cosine x plus, what is that? 2 sine x. And then, the derivative of cosine is negative sine, right? So I'm going to put a negative in front and say sine x. All right, dang it. I don't see a shortcut here. I could take a 2 out of both of those. Ooh, what is that? If I take a 2 out of both of those, I get 2 cosine squared x plus, minus sine squared x. All right, so this is just our first derivative. I took the 2 out just to make it look less confusing, but let's see. So we could take the derivative of each of these using the product rule or the chain rule. I'm going to do the chain rule just because I think it's faster.
Isn't it like a Pythagorean theorem that has...
You guys want to do, you want to make this into a 1. That would only work if this was plus. If that was plus, this would be a Pythagorean identity, which equals 1. I know, I got kind of excited. I thought that was going to happen, and then I saw a negative, and I got sad. Okay, so let's go. Let's just keep the 2 outside. He's just going to chill out there. Let's take the derivative of this guy. That means I got to drop the 2, so I get cosine x, and then I have to multiply this by the derivative of cosine x. What is the derivative of cosine x? That is negative sine. So I have negative sine right here. And then I'm going to put parentheses around this whole thing right here. And then I'm going to go minus. Now I got to do the derivative of sine squared x. Now the outside function is your squared. That's what I'm doing here. So I go 2 sine x. And then I have to multiply it by the derivative of sine x. What is the derivative of sine x? That is cosine x. Wow. Okay, let's clean this up a little bit. We have negative 2 sine cosine minus 2 sine cosine. Oh, those are like terms, aren't they? So I get negative 4 sine cosine. And then I have to multiply it by 2, so I get negative 8 sine x cosine x. There's your second derivative. Don't forget, I'm not going to do this one all the way. Your calculus point slope form equation looks like this. Okay, A is in this problem, this is your A. Okay, here's your F. You just have to find the F prime, and then you start plugging everything in, and then you're done. Okay, so to find the points, you have your negative 1, which is right there. You plug the negative 1 into the original function. That's going to be your x1, y1. I'm sorry, I'm using algebra 1 talk now. And then this right here is your m. That's your slope. You got to find the derivative of this and then plug in negative 1 to find your slope. That's how you find the tangent line equation. So yeah, some of you guys were confused about this when you came in and asked questions. It says find the points on the curve where this is tangent to the perpendicular. Oh, where the tangent is perpendicular to this. Okay, so if the tangent is perpendicular to this guy, we need to know the slope, the perpendicular slope to this guy. Yeah, so no, the slope is not 1. Remember, y equals mx plus b. The slope is right next to the x. The slope is multiplying to the x. So what is multiplying to the x right here? Here, let me do a little manipulation to help you out. What is multiplying to the x? Negative 1 over 24. So what is the opposite and positive of negative 1 over 24? 24. So the perpendicular slope here is 24. This is the slope of the tangent line that we're looking for. That's what this guy's talking about. So we need y prime, and we're going to take y prime and set it equal to 24. How do you find y prime? Well, you got to take the derivative of this, and then you're going to set it equal to 24, and then you're going to solve. Shall we do it? All right, what is y prime? It is 6x squared minus 6x minus 12, and then the derivative of 20 is 0. So we got 20 equals 24. All right, so we have to move the 24 over, so we have negative 36, negative 6x, 6x squared. It looks like I could take out a 6 from all those. So if I factor a 6 out, I get 6x squared minus x minus 6. And then I factor that. What times what gives me negative 6 adds to negative 1. We got 6 times x minus 3 and then x plus 2. So negative 3 and positive 2 will multiply to give me negative 6, add to give me negative 1. That's how I got that. And then I get x equals 3 and negative 2. So here it says find the points. What did we find? Did we find points? Yeah. No, we found x values. We have to find the points. So how do I find the y's? What do I do? What do I do? Plug the x's into what? Y prime or to y?
Y.
Oh, yeah, y. You plug it back into the original one. So you got to plug 3 into these, and then you guys will get the y value right here. All right, yeah, so plug 3 into those and find those. I'm not going to do it. This is the same question, except it says it has to be parallel to this. So what's the slope of this? It is negative 12. So what does the y prime have to equal? Negative 12. Then you solve for x's, then you get your answer. Beautiful. I like that problem. Okay, this one right here.
Hey, Mr. Patey, why is the
All right, this question says, find the point on the graph of this at which the tangent line has the same slope as the line through this. All right, so that means we're going to find the slope of this. Yeah, so you guys know how to do that, right? You subtract the y's on top, and you subtract the x's on bottom. Make sure you stay in order. So if you do this one first, and you got to do this one first. So I get 2 over 4, which equals 1/2. So the slope has to equal this. So this has to equal y prime. And then you just have to solve it. Find the points on this graph, right here, on this curve, where the tangent line is the same as 1/2. That's what this is saying. So what is the derivative of that? Do we have to do chain rule in that one?
No.
Let's rewrite it. 4x to the 1/2. Is there a function inside of the function here? Nah. Now if you do chain rule, you'll still get the same thing. So I drop this. I drop the 1/2. I get 2. Now I get raised to the negative 1/2, which is 2 over the square root of x. I put the x in the bottom because of the negative exponent. Is everybody safe? Everybody's good? Nobody's stopping me? All right. So then we're setting this equal to 1/2. Do you guys know how to solve that? Since you have a fraction equaling a fraction, we could just, do the cross multiplying thing. That times that equals that times that. So we have 4 equals rad x. How do we get rid of the radical? Square both sides. X equals 16. Oh wait, that's not a point, huh? So we got to take the 16, plug it in to get the y value. What am I plugging the 16 into? Am I going to plug the 16 into y, or am I going to plug it into y prime? Yeah, back into y. So if I go 16, is this the square root of 16? 4, and then 4 times 4? Okay, so it's 16, 16.